Welcome to your channel that teaches you corporate English every day.
Error 1. Starting to code before framing the boundary of the problem 1. Deep explanation backend. Projects don't fail because code is wrong, they fail because the starting conditions were wrong. When you begin coding without first declaring what the system is not responsible for, you create an open container where every new idea can later be inserted as if it were expected. From that moment, the project stops being finite and becomes evolutionary chaos. Code is not the problem, the absence of a boundary is. 2 early detection signals. You can detect this mistake in the first week by listening for questions like, "Are we also doing feature X? Nobody knows." Architecture discussions happening before business intention stabilizes. Tasks being added without impact review. People saying we will see that later instead of making a decision now. 3. How to prevent correct you fix this before code exists. Write a non-goal. List explicit things the system will not do. Block new scope until cost and impact are explicitly approved. Align the business constraint. Before aligning technical design, treat uncertainty as a blocker, not as something to push into the future. For a realistic example, a bank starts an internal API layer for accounts. Halfway through, product asks, "Can you also expose loans and cards since it's already being built?" Team says yes. Now the architecture must serve 3 domains instead of 1. The project doubles in complexity without doubling the budget. And now the blame will land on engineering, even though the root was boundary failure. 5. Financial operational consequence A. Backend without boundary never finishes, which means cost continues and trust declines. Projects like this don't die in code, they die in reputation and budget erosion. 6. How you explain this in a meeting. We are not failing because of code. We are failing because the system was allowed to include anything. Until we define what this project will not do, there is no such thing as done. *ERROR 2. Choosing architecture based on preference instead of constraints. 1. Deep explanation. You do not choose a backend stack because it is popular, elegant, or comfortable. You choose it because it survives the constraints. Architecture is not a personal preference. It is a response to business pressure, throughput, latency, SLA, regulatory conditions, lifecycle cost, and risk profile. When you pick architecture before defining constraints, you architect for a fantasy instead of reality. 2 early detection signals. You can detect this mistake immediately when you hear, "We always use this stack. This is what I like." Architecture was chosen before volume. SLA or compliance were even discussed. No document. Connects the stack to the expected constraints. 3. How to prevent collect constraints. First, traffic. Durability, memory, security, cost to maintain. Force the architectural justification to reference constraints, not opinions. Require a second reviewer who was not part of the decision to break bias. Reject architecture proposals that cannot articulate. Cost of ownership. For realistic example, a startup builds a high-frequency pricing engine using Python because the team knows it. Later, they discover the execution must run under 10 milliseconds. The language was never chosen for that constraint. Now, they must rewrite under pressure instead of deciding correctly at the start. 5. Financial operational consequence. Wrong architecture causes rewrite cost, delays, SLA violations, and opportunity loss. You don't lose money because the code is bad, you lose because the chosen technology was misaligned with physics and risk. 6. How you explain this in a meeting. A stack is not a matter of taste. It must be justified by the constraints. If the constraints are not written, this architecture is a guess, not a decision. *ERROR 3. No single source of truth for data. 1 deep explanation. Backend systems do not break only because of bugs. They break because different parts of the organization compete for authority over the same data. When more than one system believes it is the truth, you do not have a technical problem. You have a contradiction engineered into the architecture. From that point forward, every integration becomes a dispute of ownership instead of a flow of information. That is structural failure, not incidental failure. Too early detection signals, you can detect this before launch if you notice. Two teams say our system is the correct value. API responses differ for the same entity depending on where you call. People speak about fixing manually later. Instead of establishing rules, data conflicts are treated as bugs instead of design. Flaws 3. How to prevent correct. Designate one system as master for every critical field. Other systems must consume or cache, not co-own, for every conflict scenario. Declare a winner rule in advance. Reject deployments where ownership is ambiguous. For realistic example, an e-commerce platform treats both ERP and checkout as sources of stock truth. During a sale event, values desync. Clients get charged for items that don't exist. The problem is not availability. The problem is dual authority. 5. Financial operational consequence. Multi-master truth forces refunds, conciliation, incident time, and regulatory exposure. You don't lose money from the bug. You lose money from lack of governance of truth. 6. How do you explain this in a meeting? This is not a bug. This is a governance failure. Till we define a single system of record, every integration will break by design. Asterisk error for designing for delivery instead of designing for maintenance. 1. Deep explanation. Most leaders treat development as the cost and maintenance as an afterthought. In reality, development is the cheapest phase of a backend. It's expensive. Part is running, fixing, logging, securing, and evolving it across years. When you design only to ship, you build systems that are financially impossible to sustain once they are live. To early detection signals, no owner defined after release, no monitoring, no rollback plan, no observability baseline. PR is accepted because it works. It's not because it survives production. All trade-offs bias toward speed. Never longevity. 3. How to prevent correct. Ask, how will we support this for 3 years? Before, when can you deploy? Make logging alerts, rollback mandatory, not optional. Assign operational ownership before coding starts. Reject solutions that reduce build time, but multiply support time. For realistic example, a marketplace launches a payment service. Fast with zero observability. When incidents begin, engineers cannot diagnose root cause. Every hour of outage costs revenue, while the team is blind. Cost now exceeds the cost of building it properly in the first place. 5. Financial operational consequence. This mistake converts velocity into debt that compounds, not technical debt, but cash burn and reputational decay. 6. How you explain this in a meeting. Shipping is not the cost. Running is the cost. If we design only for delivery, we are committing ourselves to an infinite operational burden. Asterisk error. 5. Confusing speed with actual progress. 1. Deep explanation. A backend does not move forward just because code is produced quickly. Fast execution without alignment creates systems that run today and collapse tomorrow. Many teams are praised for shipping fast, when in reality, they are accumulating silent instability at high speed. Motion is not progress. It is only progress if it is in the right direction and under the right constraints. To early detection signals, you can see this mistake before the system fails by noticing. Demos focus on it runs instead of it is safe and repeatable. Business pressures override. Architectural reasoning, temporary shortcuts, become permanent without review. People treat velocity as success instead of risk acceleration. 3. How to prevent correct measure cost of consequences. Not only speed of delivery, require justification of direction before approval. Of execution block features built on top of unresolved ambiguity. It's normalize stopping development when alignment is missing. For a realistic example, a fintech rushes features to win investor timelines. 6 months later, auditing reveals inconsistencies across ledgers. Now the company must freeze roadmap to fix fundamentals, losing the exact speed advantage they thought they had. 5. Financial operational consequence. Speed without governance converts into expensive rework, regulatory exposure, loss of trust, and time lost correcting avoidable mistakes. 6. How you explain this in a meeting. We are moving fast in the wrong direction. That is not acceleration. That is structured failure with a shorter runway. Asterisk final closure. Spoken style conclusion in English backend. Projects do not collapse because one engineer made a typo. They collapse because the project was born with the wrong logic of governance. If you start without boundaries, if you choose architecture without constraints, if truth has no owner, if you design for launch instead of for life, and if you confuse speed with progress, the failure is not a surprise. It is scheduled. You prevent back-end disasters not by hiring better developers, but by making better decisions before development exists. A strong back-end is not the result of good code. It is the result of correct thinking before code is allowed to begin. That is what senior people understand, and juniors don't. End of the master lesson.